This tutorial is titled Section 1, Solving Systems by Graphing. It has the following objectives. First, we want to be able to identify solutions of systems of linear equations in two variables. Second, we want to be able to solve systems of linear equations by the graphing method. A system of linear equations is a set of two or more linear equations containing two or more variables. A solution of a linear system with two variables is an ordered pair that satisfies each equation. When we say it satisfies each equation, that means if you plug the point into the equation, it'll be true, and it must create a true statement for both equations. If so, the ordered pair is called a solution, and it will make both equations result in true statements. An example of a true statement would be 1 equals 1, and an example of a false statement would be 1 equals 0. Here's our first example, and it asks, is the ordered pair 4, 1 a solution to the following system? So as we stated previously, in order for a point to be a solution, it must result in a true statement once it is plugged in. So if we take 4 and plug it in for x, and we take 1 and plug it in for y, this first equation would become 4 plus 2 times 1 equals 6, which becomes 4 plus 2 equals 6, which becomes 6 equals 6, which is true. If we plug in 4 for x in the second equation and 1 for y in the second equation, we get 4 minus 1 equals 3, which becomes 3 equals 3, which is true. Since the ordered pair created true statements for both equations, this is indeed a solution to the linear system. Example 2 asks, is the ordered pair negative 1, 2 a solution to the following system? So once again, the first point is x, the second value is y, and we're going to plug in negative 1 for x, so we get 2 times negative 1 plus 5. We're going to replace y with 2, so 5 times 2 equals 8. 2 times negative 1 is negative 2. 5 times 2 is 10. And negative 2 and 10 combine to equal 8. So we see this is a true result. If we plug negative 1 in for x of the second equation and 2 in for y, we get 3 times negative 1 minus 2 times 2 equals 5. This gives us negative 3 minus 4 equals 5. This gives us negative 7 equals 5, which is false. Therefore, we say negative 1, 2 is not a solution. The goal to solving a system of linear equations is to find a point which both lines have in common, or more simply, find the point of intersection. So we see that in this first equation, we want to graph the line y equals 2x minus 1. We start by plotting the y-intercept at negative 1, and we use the slope of 2, which is the same as 2 over 1, to generate additional points. So we go 2 up, 1 over, 2 up, 1 over, and we generate some points. I can go back to the y-intercept and reverse the motion to 2 down, 1 left, 2 down, 1 left. And all of these points stay in line, and we can connect them. And now we'll do the same for the second equation. We see the y-intercept is at positive 5, and the slope is the number multiplying x, which is negative 1, which can be written as negative 1 over 1. So we'll go 1 down, 1 to the right, 1 down, 1 to the right, and we continue to do this. We see that these two lines intersect at the point 2, 3. So we can double check this by plugging 2, 3 into both equations. So the top equation becomes 3 equals 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. So it is true for the top equation. And in the bottom equation, it becomes 3 equals negative of 2 plus 5. Negative 2 plus 5 is 3, so we get 3 equals 3. It is true for the bottom equation, so that is our double check to say that 2 comma 3 is the solution to this system of equations. Let's do this again. You can pause the video, work it out on your own, see what you get for an answer, and then unpause it to compare it with my result. The y-intercept is at negative 3 for the first equation with a slope of positive 1. And the y-intercept is negative 1 for the second equation with a slope of negative 1. We see that the two lines cross at 1 comma negative 2. So we will plug in 1 for x and negative 2 for y in both equations to see whether they produce true statements. So the top equation becomes negative 2 equals 1 minus 3. 1 minus 3 is negative 2, so the first one is true. And the second equation becomes negative 2 equals the negative of 1 minus 1. And negative 1 minus 1 is negative 2, so the second one is true. So we double checked, and we're confident that 1 comma negative 2 is the solution. So here in example 4, we have a slight difference between the problems where everything we've received so far was in slope-intercept form. We need to rearrange the first equation. So rewrite x plus y equals 0 into slope-intercept form. And to do that, we just have to get y by itself. So we subtract x from both sides, and we get y equals negative x plus 0. This means that we will start at 0 for our y-intercept, and the slope is negative 1. So we'll generate our points by going 1 down, 1 to the right. Or we can go 1 up, 1 to the left. We connect these points together. And the second equation is in slope-intercept form, so we can begin by plotting the y-intercept at 1. And here the slope is negative 1/2. So it means 1 down, 2 to the right. And we see that these points are getting further away from the line. So we're going to go back to the y-intercept, and instead of 1 down, 2 to the right, we're going to go 1 up, 2 to the left. And we see that all these points are in line and that the equations intersect at negative 2, 2. So to verify that this point is the solution, we plug negative 2 in for x and positive 2 in for y. And we see the first equation produces a true result. And we'll do the same thing in the second equation. Plug in positive 2 for y, and then we have negative 1/2 times x, which is negative 2. A negative times a negative is a positive, and 1/2 times 2 is 1. So 1 plus 1 is 2. Yes, the second equation produces a true result. We are confident now that negative 2 comma positive 2 is the solution to this linear system. So that's the end of this tutorial. Review this video, pause it, take notes as needed. The next topic will be solving word problems by the graphing method. So be comfortable with the mechanics of solving a linear system by graphing first. After you've done all of the sections of notes and practice, complete the section 1 practice on the website, then check your answer with the answer key. Once you feel confident, go on and take the section quiz.